All right, let's take a look at the next homework problem. And for this homework problem, I'm given a velocity time graph which represents a particle that's moving. And for the very first question, I need to figure out at what times is the particle at rest. Okay, so when we're talking about a particle at rest, this basically means that the particle is not moving. And when you're not moving, that basically means that your velocity should be equal to 0. So when you're given a velocity time graph, you're basically looking for the x-intercepts. So there's an x-intercept at 0, there's an x-intercept at 3, there's an x-intercept at 5, and there's also an x-intercept at 7. So the times when the particle is not moving is when, actually, let's just write down times. So the times would be at 0, 3, 5, and 7 seconds. And hopefully that makes sense. When you have 0 velocity, you shouldn't be moving. Okay, let's move on to the next question, question number 2. And for question number 2, the question is, at what times is the particle changing direction? Okay, so I need a little bit of time to kind of explain this. When you're given a velocity time graph, and when you are above the x-axis here, so this red region represents when you are above the x-axis, and I guess this part right here is just 5. Basically, this region right here represents the particle that's moving away. Okay, so when you're above the axis there, you are moving away. So sometimes in class we'll say that when v of t is greater than 0, that means above the x-axis. This represents that you are moving away. And when your velocity is below the x-axis, this means that you're coming back. Okay, so I would say from this region right here, this part right here, you're below the x-axis. So this region right here, you're actually coming back. And then you're also moving away from 6 to 7 seconds. So this is going to be 7 seconds there. So this region right here, you're also moving away, right? Okay, so you need to know when you're moving away and when you're coming back, and it has to do when you're above or below the x-axis. Okay, so at what times are we actually changing directions here? Good question here. So basically, if I look at 5 seconds, just take a look at 5 seconds there. It looks like we are moving away in this direction, and then we're coming back. All right, so we're moving away, and then at 5 seconds we're not moving, and then everything past 5 seconds we're kind of coming back. So at 5 seconds we're definitely changing directions, and by using that same logic, when we're at 7 seconds we're also changing directions, right? So in this region right here, we are coming back, and then we go to a velocity of 0, not moving, and then we are moving away, right? So at 7 seconds we're also changing directions. Okay, that's it for question number 2. Let's move on to question number 3. Find the speed of the particle at time t equals to 6. Okay, so 6 seconds. I guess if I go straight down, the velocity that I have there is -2, right? So when we're talking about speed, there's a little definition for that for our course, and that's the absolute value of your velocity. And what's the absolute value at v of, whoops, not -6, but v of 6 seconds here? And that's actually going to be the absolute value of -2, and that's going to give me 2 meters per second. So that is the speed of the particle at time t equals to 6 seconds. Okay, let's move on to question number 4 here. So question number 4, I need to find the acceleration of the particle at time t equals to 5. And when we're looking for the acceleration, when we're given a velocity time graph, that's basically the slope of the graph. And so when I'm looking at 5 seconds here, so this is just a linear line, so we just need to find the slope of that line, right? So that slope is negative, and if I look at the rise right here, the rise is 2 and the run is 1, so the slope equals to 2 over 1. So if I want to write this correctly, I would write a of 5 equals to -2 over 1. That's the slope, right? Rise over run, and that's going to be equal to -2 meters per second squared, using the proper units there. Okay, let's move on to question number 5 now. Question number 5, I need to find the average acceleration. So for average acceleration, I know that's just the slope of the secant line, the y2 minus y1 over x2 minus x1. And I want to find that from time t equals to 1 to time t equals to 7. So average, AVG, acceleration, ACC, equals to the y2 minus y1. So that's basically going to be v of 7 minus v of 1, all divided by 7 minus 1. Okay, so the denominator is a little bit easier to calculate. 7 minus 1 is going to be 6. All right, so when you're at 7 seconds, the height is going to be 0. That was one of the times when you're not moving. And when t equals to 1, the height is going to be 2, right? So 0 minus 2 is going to be negative 2 divided by 6. And this is going to be equal to negative 1 over 3. And the units for acceleration is meters per second squared. Okay, let's move on to question number 6 now. Question number 6. During which time intervals is the particle moving in the negative direction? Okay, so negative direction, what does that really mean? It means when is the particle coming back? All right, so when are we coming back? And coming back means that's basically when the velocity time graph is below the x-axis, right? So when are you below the x-axis? Well, you're below the x-axis from here to here, that V shape there. And that starts from a time of 5 seconds and it ends at a time of 7 seconds, right? So the way you can answer that is I would put my 5 seconds on one end, the 7 seconds on the other end. I would put time in the middle, and we're between 5 and 7 seconds. So there's your answer for that particular question. So negative direction just means you're coming back, and coming back means you're below the x-axis. Okay, so between 5 and 7 seconds. Okay, let's move on to the next question here. Okay, so during which time intervals is the speed of the particle decreasing? Okay, the speed of the particle decreasing. Justify your answer. Okay. All right, so if the speed of the particle is decreasing, that basically means two things. Basically, that means the sign is different. That's the reasoning, right? So what does that mean the signs are different? So that means v of t is, we can say that's going to be greater than 0, and that means the acceleration has to be less than 0. Okay, so these signs, one's positive and one's negative, right? So that is what we mean by the signs are different, and that means the speed of the particle is decreasing. Okay, so let's look for situations where we are above the x-axis and have a negative slope. Okay, so here's one region right here. That red line represents that we're above the x-axis, but we have a negative slope. And here is another region where we're above the x-axis but have a negative slope. So those times are between 2 to 3 and from 4 to 5, right? So between 2 to 3 seconds and 4 to 5 seconds. So how do we write that? Between 2 and 3, well, we'll put the 2 over here, we'll put the 3 over there, we'll put the t in the middle, and it's always going to be less than. And we also have a time between 4 and 5 seconds. So how do I write that? Let's put a 4 here, a 5 there, a time in the middle, and the signs are always going in that direction. Okay, so those are two regions where the speed of the particle is decreasing. Another region where the signs are different is when v of t is less than 0, but a of t is greater than 0, right? So is there a region where we're below the x-axis but we have a positive slope? And the answer is yes. If I look at this red line right there, we're below the x-axis but we have a positive slope. And that is happening between 6 and 7 seconds, right? So another time where we are where the speed of the particle is decreasing is when the sign is different, and this is another example where the signs are different. Below the x-axis, but the slope is positive, and that's happening between 6 and 7 seconds. So let's put the 6 over here, the 7 over there, time in the middle, and the signs always point like that. So those are the times where you are where the speed of the particle is decreasing. Okay, let's move on to the last two questions here. So now we have this question here where I need to find the total distance traveled by the particle from t equals to 0 to t equals to 8 seconds. Okay, so before I do a question like this, if I just draw a little axis here, and if I just draw a box like that, I'll label this as my velocity, and this will be my time. And maybe I'll ask you, what does the area underneath the graph represent? Well, it's just a rectangle, so the area would be just base times the height. And what's the base? Well, the base is time, right? So the base is time, and what's the height? Well, the height is just your velocity, right? Okay. If you go back to some of your classic physics equations, I know that velocity is actually just distance over time. And then if I move the t over, I have velocity times time equals to the distance, right? So when I multiply time and velocity, which I have over here, velocity and time, we actually get distance. So what we're trying to say here is that the area underneath the curve for this velocity time graph, that represents distance. Okay, so if I want to find the total distance traveled by the particle from 0 to 8 seconds, I'm just calculating the area underneath the curve. Okay, so that's not too bad, right? So let's take a look at this region right here, which is a triangle. So base times height, so the base is 1, the height is 2, base times height is 2, divided by 2 is 1. So this area is going to be 1. If I look at this rectangle here, the area of a rectangle is base times height, so 2 times 1 is 2, so this area is going to be 2. And then by symmetry, this is going to be 1. And then if I take a look at this triangle here, the base is 2, the height is 2, so base times height is 4. 4 divided by 2 is going to be 2, so that area is 2. And then by symmetry, this area is also going to be 2. And then by symmetry again, this triangle over here is going to be has a value of 1. So if I add up all those numbers, 1 plus 2 plus 1 plus 2 plus 2 plus 1, that's going to give me a total of 9 meters, I believe, right? So 6, 7, yeah, 9 meters there. So the total distance should be 9 meters. All right, so total distance, or distance in general, just means the area underneath the curve for a velocity time graph. And please look at this explanation here on how we get to that conclusion on why the distance is the area underneath the curve. Okay, final question here. It's the same graph, and for question number 9, the question is, how many seconds will it take for the particle to reach the farthest distance from the origin? Justify your answer. Okay, so this is a combination of some of the previous questions, and it also has to do with the total distance, right? So one thing that we did mention in a previous question, such as question number 2 and question number 6, we have to figure out how the particle is behaving in this particular graph here, right? So if we're above the axes here, that means we're moving away. All right, so I believe that was kind of repeated in a previous question here. That means we're moving away. All right, so from 0 to 5 seconds, we're moving away, right? Okay, so from 0 to 5 seconds, we are moving away. And let's just say the origin is this particular dot right here. This is their starting point, the origin, right? And if I start calculating the distance here, so from the previous question, I know this distance was 1, this area was 2, this was 1, and that was also 2. So if I look at the total distance traveled from 0 to 5 seconds, I believe I have 6 meters, right? So 1 plus 2 is 3, 4, 5, 6. So basically what that means is from 0 to 5 seconds, we've actually traveled 6 meters away from the origin, right? 6 meters away from the origin. Okay, but now let's take a look at the next part of the graph where we are below. So from this region right here, we're below the x-axis. So basically from 5 to 7 seconds, right, we are below the x-axis. Okay, so when we're going from 5 to 7 seconds, we're definitely below the x-axis. And we also know from the previous question that this area is 2. And when we're below the x-axis, that means we're coming back. All right, we're not going away. So from 0 to 5 seconds, we're moving away, right? But from 5 to 7 seconds, we're actually coming back. All right, so we're coming back by 2 meters. Okay, so if we're coming back by 2 meters, that means we're actually now 4 meters from the origin, right? So we're coming back by 2 meters. So we're actually 4 meters from the origin then. And then finally, if I take a look at this last part, if I go from 7 to 8 seconds, which is this region right here, 7 to 8 seconds, what's happening from 7 to 8 seconds? Well, from 7 to 8 seconds, we are now moving away, right? We're moving away from the origin because we're above the x-axis. And from the previous question, I know that this distance right here is going to be 1, right, by symmetry, right? So the total distance traveled is 1 meter. All right, so we're actually moving 1 meter away from home again. So then from here to here, I need to add 1. So this will be 5 meters away from home. And then, sorry, we were actually subtracting 2 meters from that situation here. Okay, so when I take a look at all these, all the distances here, it looks like from here to here, this is the farthest distance from the origin, right? We're 6 meters away from the origin. So how many seconds will it take for the particle to reach this farthest point from the origin? I would say it would be 5 seconds, right? From 0 to 5 is 5 seconds. Okay, so I hope that explanation was okay. Basically, we're just breaking down the total distance into a nice little table here. And 6 meters represents the farthest distance from the origin.